first order conditions. And what do those first order conditions tell us as a matter of economics? Well, let's think about, take the ratio of any two of these first order conditions. Partial u partial xi divided by partial u partial xj equals pi over pj. So any pair of those equations, I could take the ratio of those equations to give me that formula there. What does that tell me? How do you interpret that equation? What does the economics do? Yeah.
Marginal utility of substitution.
Well, but try to say it more in English. Try to explain to your mom. Your mom, what the hell are you talking about? Okay, well, let's talk about the two sides of the equation, because I actually think of the two sides of the equation quite distinctly. So, for example, what is this? It is the ratio of prices, but let's step further. What ratio? What does that ratio tell me? What you give up? What would you have to give up? How much would you have to give up of which good to get which one? Which one? Which way? It's how many units of good J you have to give up to get a unit of good I. Otherwise known in economics as the cost of good I, expressed in terms of units of good J. Right? So this is the cost of good I. And because I divided by Pj, it's expressed in terms of units of good J. It says it takes you got to give up 3 units of good J to get a unit of good I. That's what it says. Right? It says it costs me 3 units of J to get a unit of good I. This is what we call, in economics, I think about this as the cost. This is the cost of consuming good I. The more I want, the less J I get. Or I could have divided by K, less of all the other goods. If I want to consume more I, my budget constraint says I got to consume less of something else. One of the things I can consume less of is J. Okay. What is this? What does that ratio measure? Yeah, that's a good term. I usually use the term value. It's how much I value good I in terms of good J. It's the amount I'm willing to give up of good J to get a unit of good I. Right? Why does that measure the amount of good J I'd be willing to give up to get a unit of good I? Because it's what holds, it keeps my utility constant, right? That is, if you give me this many units of good J per unit of good I, that holds my utility constant, right? I mean, think about it. If, like, say, the margin utility of a good I is 3, and the margin utility of good J is 1, then if I gave you 3 units of good J for every unit of good I you gave up, you'd be just as well off, because you'd be losing just as much from getting less I as you'd be gaining from getting more J. Right? So people call this the marginal rate of substitution, but really, in economic terms, it's really the value of good I in terms of J. Okay? Value of good I. And so this first order condition says, in order to be at an optimum point, you have to be at a point where what it costs you to consume more I equals how much you value consuming more I. What would be true if this wasn't the case? What if this didn't hold? What if this side was bigger than that side? Could you be at an optimum? You would take less J and more I, you'd be better off. The market says I only have to give up 3 units of good J to get a unit of good I. I'm willing to give up 5 units of good J to get a unit of good I. I can make myself better off, right? This is what we always get in economics. This is the marginal benefit. This is the marginal cost. And if you really understood that, you're like 90%, I don't know, 80% of the way through economics, right? That's 80% of economics right there, right? It's just finding that in every problem is really the key. How do I find that key element? How do I identify the marginal benefit? How do I identify the marginal cost? And how in the world do I figure out where those two things are equal? Okay. So that kind of is a very simple way to think about it.